Welcome, class, to the first lecture of Stat 215. This lecture will cover section 1.1 in our textbook. To start off, let's cover the basic definition of statistics. Statistics is the science of collecting, organizing, and analyzing data for the purpose of estimation and making inferences. Our textbook and this course will focus on statistics as it pertains to science and engineering. The basic idea of this course will be to learn about a population by studying a small subset of the population, and by learn, this means to estimate or infer something about the population. For example, in 2016, TV stations conducted polls of U.S. registered voters across the country to predict who would win the 2016 presidential election. As statistics is used in the science and engineering, it is no surprise that the process of developing and understanding statistics also follows the scientific method. Step 1, we observe. Step 2, we construct a conjecture or a hypothesis. Step 3, design an experiment. Step 4, collect the data. Step 5, analyze data using statistical methods. And step 6, conclusion. Steps 2, 3, 4, 5, and 6 will be things that we focus on in this course. This course will focus on two major branches of statistics, descriptive statistics and inferential statistics. Descriptive statistics uses graphical displays and numeric summarizations to represent data. This type of statistics will be covered in Chapter 1. In inferential statistics, we use analytic methods and theory of probability to draw conclusions and make decisions. This is covered in the chapters after Chapter 1, so chapters 2 and beyond. Our next few slides will focus on the design of experiments, or the ideal way to collect data, which is generally through random sampling. But first, it is important to define population and sample, as we have already used these terms in the definition of statistics, and will need an understanding of these terms going forward. Population is the entire collection of objects or people that one desires to study, usually to make an inference about the population or to estimate a population parameter. Sample is a subset of the population. Under the field of populations, we have two subcategories. First is what is known as a real population. This consists of a finite number of members, actual objects, from which data can be collected. For example, the population of all college students in the United States, or the population of all legally registered automobiles. The other type of population is conceptual population. This exists only as a concept and can be thought of as an infinite number of members. For example, the tossing of a fair coin. Or another way to think of a conceptual population is a population that is consistently growing. So if you recall on the previous slide, we defined population and sample. This is to help us understand the ideal method of sampling. A simple random sample of size n is a sample chosen in such a way that each subset of size n from the population is equally likely to comprise the sample. So the first example is if we have a population that is of all current WVU students, and the sample, say a subset of size 200 of current WVU students. This would be considered a real population. A second example would be a population of all possible outcomes of tossing a fair coin an infinite number of times. The sample would be to toss the coin, say, 30 times. This is a conceptual population. A convenience sample is obtained by some method other than a well-defined random method. For example, a population of all Kmart shoppers. The sample could be, say, the next 50 shoppers that exit the Morgantown Kmart. Convenience sampling is usually done when random sampling is simply not a possibility. As we are collecting these samples, we should be aware of something known as sampling variation, which is different random samples can produce different results. For example, two students are more than likely not going to get the same results from 30 flips of a fair coin. This is expected and is part of the reason why we run multiple samples, and using those random samples, we usually average them out to make a better estimate. It's just something to be aware of going forward, but it's not something you should be particularly stressed out of at this moment. But with our samples, we will ideally have samples that have some degree of independence. The items, observational units, in a sample are independent if knowing the value of one item does not provide information about the values of the other items. Items in a simple random sample may be treated as independent so long as the size of the sample is less than 5% of the size of the population. Some other sampling methods we should concern ourselves with is stratified random sampling. The population is divided into subpopulations called strata, and a simple random sample is selected from each strata. For example, sometimes we use stratification in medical studies, particularly with the variable age. If you notice, oftentimes for medication doses, children and adults have different dosages. That's probably, because children and adults have different physiologies and the doses would have different effects on them. So in conducting the medical studies, those that were children were studied separately from those that are adults. This is very common in many different types of studies. I've seen it personally most often in medical studies. Next, we have cluster sampling. Items are selected from the population in groups or clusters. That brings us to the end of our sampling method sections, but now we will focus on types of data. A very important definition for this class is variable. A variable is a characteristic whose value is observed for each unit in the sample. Data are values which arise from observing a characteristic, i.e., the values of a variable. So to break down the types of data we'll be using, variables can be classified into one of two types. 1. Numeric, 2. Categorical. Numeric variables are variables whose values represent quantities. For example, 5 years old, 190 pounds. Numeric variables may be further classified as discrete or continuous. Discrete numeric variables usually arise by counting, whereas continuous numeric variables typically arise by measuring. Their values form a range or an interval of possible values. Some examples: for discrete, the number of cars in a parking lot, the number of credit hours you are taking in the fall semester, or the number of books you own. Some example of continuous numeric variables is the height of the person, or the amount of time studying, or the weight of an apple. Question: is the variable age discrete or continuous? Well, to be honest, it depends. Usually it's treated as continuous, but depending on how it is used in a sample, it could possibly be discrete, or even if we break it down into categories of, say, young, adult, and old, we could make it into a categorical variable. Categorical variables are variables whose values are non-numeric. For example, gender, class rank, blood type, and Stat 211 course grades. If the possible values of a categorical variable possess a natural ordering, the variable is called a ranked or ordered variable. So, for example, course grades have the natural ordering of A, B, C, D, F. Okay, so this slide here is a bit of a typo. It's talking about outliers and should actually be in the next section, so we're going to skip this for now. So instead, let's talk about some notation we're going to use throughout this course. X, or any capital English letter, is how we represent a random variable. When we think of the sample data before collecting the data, we will represent it as capital X's. So X1, X2, ... all the way to Xn. The actual values of sample data are represented as lowercase letters, or lowercase x1, lowercase x2, comma, ... all the way to lowercase xn. Two other important definitions we will need in this class is that of parameter and statistics. When we were discussing population and samples earlier, I didn't discuss this because this is technically in section 1.2, but it is really important for us to cover in the theoretical part, especially as we're moving forward in section 1.2, really is mostly focused on calculating statistics, which we'll define now. So a parameter is a number that describes some characteristics a number that describes some characteristic of a population. For example, mu is the theoretical mean of the population. This is something very important for you to remember, that mu is the theoretical mean of the population. You will see mu throughout this course, and it's important that you recognize what that Greek letter means. So some examples of parameters would be the mean age of the population of all college students, or the mean value of an infinite number of tosses of a fair six-sided die. Now, statistics is very similar to the parameter, only what parameter is to population, a statistic is to a sample, or a number that describes some characteristic of an example. For example, x bar is the mean of the sample. X bar, or really any lowercase letter with a bar over it, is how we choose to represent the mean of a sample. For example, the mean age of a random sample of 1,000 college students. That would be an example of a statistic. Another example would be the mean value of 500 tosses of a fair-sided die. In order to draw conclusions about a population or to estimate a population parameter, we need a sample that is representative of the population. Even though we do not have information about the entire population, the data contained in the sample can be used to make inferences about the entire population. I mentioned this a bit earlier in this video. Basically, it would be impractical for us to, or sometimes completely impossible, to sample, survey, record all the values associated with the population. It is much easier, less expensive, and practical to just take a sample and make conclusions based from that. So an example would be, we can use the sample mean, x bar, calculated from the random sample of 1,000 college students to estimate the unknown value of the mean age, mu, for the entire population of college students. Now, this sample mean wouldn't be exactly correct, but it would be pretty close. Okay, that concludes the first lecture video. Remember, if you have any questions, send me an email and I will do my best to answer them. Have a good evening. Bye-bye.